Hey guys, Miss Fearon here. Welcome to Unit 8's Notes 1. This is our first notes for our unit here when we are going to focus on simplifying radical expressions. So our learning target for today is I can simplify a radical expression. So when we talk about radical expressions, we are looking for any expression with a radical term. And we're used to seeing that term radical said as a square root. So when I'm talking about a radical, I'm talking about that square root. We are going to look at simplifying those. So we know that we're going to be simplified when there's a couple things going on. First of all, we can have no perfect squares under the radical. And we're going to go ahead and we're going to look at what perfect squares are here in a second. But when we are fully simplified, we have no perfect squares left under the radical. We also have no fractions left under the radical, as well as no radicals in the denominator of a fraction. So we're going to focus on this here today, and then the other two in further lessons here. So the way we're going to go ahead and do this today is we're going to simplify radical expressions using perfect squares. So there's a couple steps to this. First step, determine the largest perfect square that divides the number. We then want to use the product property to rewrite the radical expression. The product property is what we're going to talk about here next. So our third step then is to take the square root of the perfect square to simplify. And then we have to take note that we're going to do something a little different with variables. So watch the video to make sure you fully understand how to work with the variables. So when I talk about a product property here, that is this. When I take the square root of a times b, I can split that up into the square root of a times the square root of b. So we're really going to use that here in simplifying radical expressions when we use our perfect squares. So before we can move on and actually start simplifying these expressions, we need to know what our perfect squares are. So our perfect squares are when we take any number and we multiply it by itself, the answer we get. So these perfect squares are going to be so important for us, we need to make sure that we know them. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 and 4 is 16, 5 and 5, 25, 6 and 6, 36, 7, 49, not 81, we want 64, 9 times 9 is 81, 10 times 10, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. So these numbers right here are going to be numbers that we're going to use. These are called perfect squares, and we're going to use those when simplifying radicals. So let's look at this first example here. We are taking the square root of 50. If I plug that into my calculator, I'm going to get a decimal, and I don't like decimals. I want simplified with radical terms. So we're going to go ahead and we're going to follow our steps here. First off, we need to look at our list of perfect squares, and we want to determine what is the largest perfect square that can be divided out of 50 evenly. So I know that 50 is the max I can be, so my perfect square right below 50 is 49. Well, 49 doesn't go into 50 evenly. So then below that, I'm going to end up getting 36, and 36 doesn't go into 50 evenly. So then I'm going to go down to my lower one in that perfect squares list, which is 25. And I know 25 goes into 50. So I can actually split this up into two radicals. I'm going to do the square root of 25, and then the square root of, I know 25 times 2 gets me back up to 50. Remember, the product property tells me I can take multiply the numbers underneath the radicals and get back up to the top. So now I'm going to do this piece by piece. The square root of 25 is going to end up giving me 50. And the square root of 2 is going to be a decimal. So we don't want to write the decimal. We're just going to leave that the square root of 2. And I can't simplify that anymore. That's my final answer. So let's go ahead and look at the square root of 48 here. I'm going to start with my perfect squares, and I'm going to start with the largest number that could possibly go into it, which is 36. Well, 36 doesn't go into 48. Then I'm going to look at 25. 25 doesn't go into 48 evenly. I'm going to look at 16. Well, I know 16 does. So I'm going to split this into the square root of 16. And I know that 16 times 3 is going to give me 48. So I'm going to also have the square root of 3. So now I'm going to simplify each of these. So the square root of 16 is 4. The square root of 3 I cannot do. It'll give me a decimal, so I'm going to leave that as the square root of 3. And that's my final answer. Next example here, I have the square root of 32. So again, going through my list, I know that I can split this into the square root of 16 times the square root of 2. So I'm going to take the square root of 16, which is 4. Square root of 2 I can't do, so I'm going to leave that as the square root of 2, and that'll be my final answer. So now when working with variables, we're going to have to do something a little bit different here. So I know that x to the fourth is x times x times x times x. So what I'm going to do is I'm actually going to write this radical out as x times x times x times x. And here's what we need. In order for these variables to get out from underneath the radical sign, they have to be in pairs. So I can pair them up. Now, when they come out of the radical in pairs, they come out as 1. So the square root of x times x is just x. And then the square root of x times x for this is just x. So these would come out to the front and they come out as just 1. So my last step now is going to be to multiply these together. So x times x is going to give me x squared, and I'm done for that one. So let's go ahead and look at number 8 here. I'm going to actually split this into a couple different pieces. I want the number to be underneath its own radical. So we're going to leave that as the square root of 4 here. And now I'm going to do the square root of b to the third. So I'm going to write that as b times b times b. So I know that the square root of 4 is 2. And now we're going to pair up our b's. They pair up, but once they're out, they come out alone. So I have a b out here. And then I have the square root of just a single b left. I cannot bring this one out because it doesn't have a partner. So it stays underneath the radical term. So number 9, we're going to do this in pieces here. I'm going to do the square root of 75. And then we're going to deal with the square root of x times x. And then times y times y times y. So we're going to go ahead and we're going to simplify the square root of 75 first, just like we did when we had just numbers back there. I know that the perfect square that goes into 75 is going to be the square root of 25 and the square root of 3. So now my variables, I need to pair them up. I'm now going to go the square root of 25 is 5. I have an x that's going to come out and a y that's going to come out, and they come out alone. And now underneath the radical, I can't take the square root of 3, so that's going to stay, and I still have a y variable left over there. So that's going to be my final answer. So now the next 2 examples we're going to look at here, these are actually going to be ones that are just numbers. So I want you to try these ones on your own. So this is example actually number 7 and number 8. So I want you to pause the video. Remember, you're just going to look for a list of perfect squares, which perfect square goes into each number, split them up, and then take the root of what you can. So when I went and did these 2 for the first one, number 7, I got 2 root 6. And then number 8, I got 7 root 2. If you got anything different, please come check with me before moving on in the video. So now for these next examples, we have something a little bit different happening here. I have a number out front already. So I already have 3 root 18 for this one. So we're still going to look at this, and we're going to split the 18, the root 18, into a perfect square and some other number to multiply back to 18. So I know the perfect square that goes into 18 evenly is 9. So I have the square root of 9 and the square root of 2. And I still have this 3 out front. That does not have a root under it, so I'm not going to put it under a root. So I'm still going to simplify. Right now I still have that 3. The square root of 9 is going to be 3. The square root of 2 is just the square root of 2. It's going to be a decimal. So these telling me I'm doing 3 times the square root of 9. So I'm doing 3 times 3. So I end up getting 9 root 2 in the end. So number 13 is the same kind of idea here. We have a 5 root 12. So we're going to split up the root 12. So I still have that 5 out front. Root 12 I know has the perfect square of 4 times 3. So I have the 5. The square root of 4 is 2. So I'm doing 5 times 2. Square root of 3, we're just going to leave a square root of 3. So my final answer is going to be 10 root 3. So let's look at this word problem here. Number 11. So this is number 11 for us. We have a tsunami that is a destructive, fast-moving ocean wave caused by an undersea earthquake, landslide, or volcano. Scientists can predict arrival times of tsunamis by using water depth to calculate the speed of a tsunami. A model for the speed S in meters per second at which a tsunami moves is S equals the square root of G times D, where D is the depth in meters and G is 9.8 meters per second. So, we are asked to find the speed of a tsunami in a region of the ocean that is 1,000 meters deep. We want to write our solution in simplest form. So I'm going to use this formula, S equals the square root of G times D. I know that G is 9.8, so I automatically know that this is going to be 9.8, and then we're going to times that by D, which is 1,000. My depth is 1,000. So when I do that in my calculator, I am actually trying to simplify the square root of 9,800. So what I'm going to do is I'm going to split this up into different radicals that I know. So when looking at my perfect squares list, I know that 100 is going to go into this. So let's go ahead and take 100 out of this right away. So I'm going to do the square root of 100 times the square root of 98. Now, when I take the square root of 100, I get 10. Square root of 98 is still square root of 98. But I think that I can simplify 98 even more. So I'm going to split 98 now into the square root of 49 and the square root of 2. So I still have that 10 out front. Square root of 49 I know is 7. And then square root of 2 we're just going to leave as square root of 2. So 10 times 7 is 70, root 2. And I know that this is going to be meters per second. So you might come across a problem with a really, really big number. And our list only goes up to a certain amount. So you always want to check and make sure that the number under the root is as low as it can go. So you might have to simplify 2 different times. Part B here is now asking us to find the speed of a tsunami in a region of the ocean that is 4,000 meters deep. So we're going to do the same idea. So we're going to have S equals the square root of G times D. So S is going to equal, I know G is still 9.8, and D now is 4,000. So I'm going to multiply that into one solid number here. So I'm going to get the square root of 39,200. So I'm going to simplify this right away using the square root of 100 because I know that can be taken out of here. And that's going to make the number smaller for us to try to find other perfect squares. So I know the square root of 100 is 10, and then I still have the square root of 392. So I need to figure out what is a perfect square that goes into 392 now. So now looking at my list then, I know that 392 can be split up into the square root of 196 and the square root of 2. So I still have that 10 out front. The square root of 196 is 14. So I have times 14, and then I still have the square root of 2. So now when I do 10 times 14, I get 140 root 2, and we're talking about speed here, so we're talking about meters per second. So your next step now is to work on that practice. If you have questions and you're still unsure of how this works, come chat with me and we'll go through a couple more examples before you move on to that practice.